Hey everyone, and welcome to another explainer from us here at Panuka.co. Today, we're diving into a fascinating question. What happens when a pure, totally natural product runs up against a super strict global rulebook? We're going to see how the very things that make a honey special can get it flagged as low quality or even as a fake. Let's get into it.
So, what are we even looking at here? It might look like a science experiment, but this is a microscopic view of Turkish pine honey. And all those little bits and pieces, fungus spores, algae, that's not contamination. Nope. That is what gives this honey its unique signature. It's not a flaw, it's character.
And that really gets to the heart of the matter, right? When we set up these big international rules to protect us from fakes and ensure quality, what happens when a perfectly good, totally authentic product just doesn't fit the mold? How do you tell a natural rebel from a cheap counterfeit?
Okay, so to get into this, we first have to understand the rule book itself. Just like any big food product that gets shipped all over the world, honey has these international standards to make sure what you're buying is the real deal and that it's safe. You've basically got two main referees in the global honey game. On one hand, there's the EU directive. That's binding law for anyone in the European Union. And on the other, you've got the Codex Alimentarius. Think of that one as a global guidebook. It's technically voluntary, but it's so influential that countries all over the world use it to write their own laws. They're pretty similar, but that whole voluntary thing can make a big difference.
So, what are these rules actually looking for? Well, it gets pretty scientific, but a lot of it boils down to three key chemical markers that kind of tell you the whole life story of the honey, from the moment the bee made it to when it lands in your kitchen. First up, we have diastase. The easiest way to think about this, it's like a built-in freshness timer. It's a natural enzyme that the bees themselves add to the honey. Now, if that honey gets overheated or sits on a shelf for way too long, the diastase activity drops. So for the regulators, a higher number is a good sign. It means the honey is fresh and has been handled with care. All right, next is HMF, and it's pretty much the total opposite of diastase. This stuff is basically non-existent in fresh honey. It's a clear marker of heat damage or just old age. So while you want your diastase number to be high, you want this HMF number to be as low as humanly possible. It's the red flag that says a honey has been stressed out.
And finally, there's electrical conductivity. Now, this one sounds super technical, but it's basically a fingerprint test. By measuring the mineral and acid content, you can figure out where the honey came from, its botanical origin. Darker, mineral-rich honeys from forests have high conductivity, while light, floral honeys have low conductivity. It's a really great tool for classification.
But here is where it all starts to get a little messy. Just look at this chart. It shows the diastase levels from over 12,000 honey samples. The range is just huge. What's considered normal is all over the place. Nature doesn't operate in neat little boxes, and that is a massive headache when you're trying to write a one-size-fits-all rulebook. And that brings us perfectly to our case study for today, pine honey. This stuff is the perfect example of a totally unique, high-quality product that naturally, well, kind of bends the rules.
Now, here's the most important thing you need to know. Pine honey doesn't come from flower nectar. It's what's called a honeydew honey. Bees in places like Greece and Turkey actually collect a sugary liquid that's secreted by insects living on pine trees. This one fundamental difference is the root cause of all its unique properties.
So because of where it comes from, pine honey is just built different. It's darker, it has more minerals, which gives it that high electrical conductivity we were just talking about. But here's the catch. It can also have naturally lower diastase activity and a lower sugar content than the international rules expect for a honeydew honey. You can probably see the problem brewing, can't you?
This leads us right to the core of the conflict. What do you do when your country's most famous, most prized honey might actually fail the big global test? Well, you adapt. You make your own rules that actually recognize and protect your natural heritage.
This table right here tells the whole story. Just look at the difference between the main EU and Codex standard and what countries like Greece and Turkey have done. For sucrose, the global standard is a super strict 5 grams. But Turkey knows its native pine honey can be naturally higher, so they created an exception allowing up to 10%. These countries literally rewrote their own rulebooks to fit the reality of their local products. Pretty smart.
And listen, this isn't just some boring paperwork debate. This quote gets right to the human cost of it all. Beekeepers complain all the time that their perfectly good products are getting wrongly judged because of a natural feature that a rigid global standard just doesn't understand. It's a real-world problem for the people who actually produce our food. But wait, the challenges for pine honey don't stop there. It's not just about the quality markers. There's an even bigger issue: fraud. And the really tricky part is, the very tests designed to catch the cheaters can sometimes point the finger at the good guys. You see, one of the biggest scams in the honey world is adulteration. That's when someone waters down real honey with cheap syrups from things like corn or sugar cane. These are called C4 plants, and their chemical signature is different from the C3 plants that bees usually visit. And that difference is how labs are supposed to catch the fraud. Now, this is where the science gets really cool and really important. The old standard test, the AOC method, tries to find fraud by looking at the honey's protein. The problem is, it's a bit clumsy. With pine honey, it accidentally grabs other natural stuff that's in there, which can skew the results and trigger a false positive for added sugar. But the new ultrafiltration method, it's way more precise. It's like a sniper. It isolates only the protein, filters out all the noise, and gives you the true, accurate answer. 7%. That's the magic number. It's the official limit for detecting cheap C4 sugar. If a test result comes back above that number, a honey gets flagged as adulterated. So for an honest beekeeper, a false positive isn't just a small mistake. It can destroy the value and reputation of their entire harvest. And that brings us to the key takeaway from all of this. The goal isn't to get rid of standards. We need them, but we need to make them smarter. We need a system that's scientifically advanced enough to catch the real criminals without punishing a natural product like pine honey, just for being itself.
So this leaves us with a much bigger question, one that goes way beyond honey. When we regulate natural products, do we just end up creating a rule book with a million little exceptions and footnotes? Or do we need to fundamentally rethink our rules to be more flexible, to embrace the incredible diversity that nature actually gives us? It's a huge challenge for our entire food system. Thanks for joining us for this explainer from Panuka.co.